Welcome back to my YouTube channel. Today we are going to study about logistic regression in machine learning. So let's start. Logistic regression is a supervised machine learning algorithm mainly used for the classification problems. Unlike linear regression, which predicts continuous value, logistic regression predicts the probability that a given input belongs to a specific class. It is a commonly used for binary classification where the output can be one of two categories such as yes, no, true, false, or 0, 1. Logistic regression uses the symbolic function to convert into probability values between 0 and 1. As you can see, this is the graph of linear regression. Let's go. What problem does logistic regression solve? Logistic regression is a supervised learning algorithm that predicts the probability of an output belonging to a particular class. Instead of directly saying class 0 or class 1, it first estimates how likely the input is to belong to a class and then makes a decision. Typically, real world examples include email classification, spam or not spam, medical diagnosis, disease or no disease, student result pass or fail. This probability based approach makes logistic regression both powerful and interpretable. Why probability matters more than just prediction? Unlike many basic algorithms, logistic regression does not jump straight to a decision. It answers the questions like there is a 92% chance that this email is spam. This probability allows flexibility. For example, in medical applications, we might use a higher threshold than zero point 0.5 to avoid risky prediction. The role of symbolic function is the heart of logistic regression is the symbolic function. Its job is to convert any real number into a value between 0 and 1, which can be interpreted as probability. Key ideas to remember: the symbolic curve looks like a S shape, output is always between 0 and 1, make classification decision possible. Decision rules commonly used: probability is greater than and equal to zero point 0.5 is class 1, probability less than zero point 0.5 is class 0. Let's see how logistic regression makes a decision. Before applying the symbolic function, logistic regression first calculate a linear score using input feature. Let's see its equation, that is z equals to w dot x plus bz equals to w upon c dot x plus bz equals to w dot x plus b, where x equals to input feature, w is model weight, b is the bias term. The value z is then passed through the symbolic function to obtain a probability which is finally converted into a class label. Let's see understanding of odds and log odds. Instead of modeling probability directly, logistic regression works with odds. Taking the natural logarithm give log odds, also called the logit. Its equation is log under 1 minus px equals to w dot x plus b. Let's see type of logistic regression. Logistic regression is not limited to binary problems. Depending on the target variable, it can be applied in different ways. First one is the binomial logistic regression, two possible outcomes 0 or 1. Next one is the multinomial logistic regression, more than two unordered classes. Third one is the ordinal logistic regression. It uses multiple ordered categories. Each variation adapts the same core idea to different classification needs. Assumptions behind the logistic regression. For logistic regression to work effectively, a few assumptions should hold. First one is the observation should be independent. The target variable should be categorical. Independent variables should have a linear relationship with log odds. Data should not contain extreme outlier. A reasonable large data set improves performance. Violating this assumption may reduce model reliability. That's all for the linear regression. Bye.